Everyone, this is Mr. Garcia, and in this lesson you are going to learn about the properties of parallel lines. Okay, so as you can see, these two lines, when you see those markings here, that means that these two lines are parallel and they're being cut by a transversal. So there is a theorem that I'm going to give you next. Okay, so that theorem says that if a transversal, okay, which is what this is a transversal, okay, intersects, which is a fancy word for cuts, intersects parallel lines then this is what happens. So we get all of these properties here. So property number one, corresponding angles are congruent. Okay, that's one property. Another property is that alternate interior angles are congruent. Another property, this one says that alternate exterior angles are congruent. And the last property, this one says that same side interior angles are supplementary. And don't forget, supplementary means they add up to 180 degrees. Okay, so let's go back and use this to help us find these properties, to help us find the measure of all the angles at this intersection. So corresponding angles. So this angle 1, we already know the measure of angle 1 is 67 degrees. So which angle corresponds to angle 1 but at this intersection? And the answer is angle 5. So since this angle is 67 and this says the corresponding angles are congruent, so then this angle is also 67 degrees. Okay, and there are different ways we can find the measure of all the angles here, but I'm going to use next one alternate interior angles, because angle 5 is an interior angle and it's alternate interior to angle 4, because they're on the opposite sides of the transversal inside the intersection from the lesson that you saw yesterday. And this one says that alternate interior angles are congruent, so then this angle 4 also has a measure of 67 degrees. Let's see, alternate exterior. I don't have an exterior angle yet, but I'll get one soon. Okay. Number 4 says that same side interior angles are supplementary, which means that angle 5 and angle 3 have to add up to how many degrees? And if you said 180, you're correct. So then to find angle 3, okay, I'm going to do this on the side. So angle 3 plus 67, which is this angle, equals 180 degrees. They're supplementary, so I'm going to subtract 67 from both sides of the equation. So then I find that angle 3 is equal to 180 minus 67, that's 113. So then angle 3 has a measure of 113 degrees. Now I can use, let's see, if angle 3 is 113, 3 is alternate interior to angle 6. So this one is also 113 degrees based on this property. Okay. Now I can use another, let's see if I can use alternate interior. So I have all the interior angles. Now we need alternate exterior or same side alternate exterior angles. Okay, so alternate exterior, angle 1 and angle 8 are alternate exterior, and this is saying that those angles are congruent. So if one is 67, then angle 8 is also 67, right? Now, so let's see what else. This one says that same side interior angles are supplementary, so that one we have used already. So what other property can we use? I think we've used them all. Let's go back to number 1, property number 1. So I see that angle 3 and angle 7 correspond, and this is saying that corresponding angles are congruent. So if angle 3 has a measure of 113, then angle 7 better also be or have a measure of 113 degrees. Now I'm going to use alternate exterior angles are congruent, and I know that 7 and 2 are alternate exterior, which means that angle 2 is has also a measure of 113 degrees. And this should check. As you know, 5 and 8 are vertical angles, but we're not using that for this lesson, okay? But as you can see, they are congruent. 7 and 6 also vertical angles. So that's just to remind you that there are different ways to find the measures of all the angles at the intersections using these properties and also what you have learned on the previous lessons. So let's go on to another example. So on this example, I'm going to draw this along with you. Okay, so just copy here what I'm doing. So let's say we have these two lines, okay, and I'm going to add something to those two lines. Let's say this is a transversal, but if you don't see this or these symbols on the two lines, do not assume that they are parallel. You have to see this arrow or triangle on the lines so that we can understand that they're parallel. Otherwise, do not assume they're parallel. Okay, so let's say that this angle, okay, this angle has a measure of x, and this one has a measure of x minus 50. Okay, so what we need to do here is we need to find the value of x or solve for x. All right. So I see that the angles, both of these angles are inside the intersection. I also notice that the angles are on the same side of the transversal, so that means that they need to add up to 180 degrees based on this property, right? So then I'm going to say that x plus x minus 50, okay, equals 180. Why? Because they are same side interior, which means that they are supplementary. So they have to add up to 180 degrees. Okay, so here I'm just explaining why I'm making this statement. So x plus x is going to be 2x. 2x minus 50 equals 180. Next, I'm going to add 50 to both sides of the equation. Okay, then I have the 2x's isolated, but when I add 180 and 50, the sum is 230. Right, next I'm going to divide by 2, which means I'm using the division property, so then 230 divided by 2 is 115. So the value of x is 115. Okay, and that's all for this lesson. I'll talk to you soon. Bye-bye.